11.1a homework, part 2. A student determined that the ordered pair 2, -5 is a solution of the following system. His reasoning was that the ordered pair satisfies the second equation, since 2 plus -5 is -3. What went wrong? Well, it has to satisfy both equations. So, let's try the first one. So 5 times x, x being in this case a 2, plus y, y in this case being the -5, is equal to 4. So 5 times 2 is 10, plus -5, that's really just subtracting 5, is equal to 4. So 10 minus 5 is 5. Is 5 equal to 4? No. So even though x plus y is equal to -3, it did not satisfy the second equation, so this is in fact not a solution of this system of linear equations. Solve the following system of equations by using the substitution method. The way we would do that is we would simply solve for one of the variables. So we could solve for this x, or this y, this x, this y, or this x, and then substitute that in to the other equation. Now in this case, since y is already being solved for 8 minus x, I'm going to use that. So wherever I see a y in the other equation, I'm going to plug in 8 minus x. The second equation is 4x minus y, y being 8 minus x equals 7. 4x minus 8, and then we can kind of think of this as a distribution of the negative. -1 times positive 8 is -8, or subtraction of 8. -1 times negative x is plus x. 4x plus x is 5x. 5x minus 8 is 7. At this point, we are going to solve for the variable x. But first, we have to get the entire variable term 5x by itself. So we have to undo the subtraction of 8 by adding 8, and whatever we do to one side, we do to the other. That gives me 5x is equal to 15. Then we undo the multiplication of x by 5 by dividing by 5, and whatever we do to one side, we do to the other, giving me x is equal to 3. At this point, we have solved for x, but a solution has to have x and y value. It has to be an ordered pair. We are missing our y. So we plug in this x into the equation we already have solved for y. Y is equal to 8 minus x. Y therefore must be equal to 8 minus 3. And 8 minus 3 is 5. The ordered pair, if we plug both these into an ordered pair, x is equal to 3, y is equal to 5. So the answer is the ordered pair of 3, 5. Now normally, as in this example, the variables are not automatically solved for, and you actually have to do a little bit of algebraic manipulation to solve for one of the variables. We have 4 possibilities, and they are all correct. The first one is I can solve for this x in the upper left corner. I can solve for the y over here, the x over here, or the y over here. Now you generally want to pick the variable with the closest thing to a +1 coefficient. It'll make the algebra of solving for it easier, but all of them will work as long as you do all your algebra correctly. I am going to solve for this x. I need to undo the subtraction of 2y by adding 2y, and whatever I do to one side of the equation, I must do to the other. Those cancel out, leaving you x is equal to 2y minus 10. What that means is, wherever I see x in the first equation, I can plug in 2y minus 10. So 2x, x being 2y minus 10 minus y equals 10. We do distribution. 2 times 2y is 4y. 2 times -2 is -20. Minus y is equal to 1. 4y minus y is equal to 3y minus 20 equals 1. We want to get the 3y variable term by itself, so we undo the subtraction by adding 20, and whatever we do to one side, we do to the other. That gives me 3y is equal to 21, because 1 plus 20 is 21. Next, we undo the multiplication of y by dividing by 3, and whatever we do to one side, we do to the other, leaving me y is equal to 7. Now that we've solved for y, we need to solve for x. We know what x is equal to. X is equal to 2y, y being in this case 7, minus 10. 2 times 7 is 14. 14 minus 10 is 4. Now we write it as an ordered pair of 4, 7, where 4 is the x and 7 is the y.